Okay, it's 5 after the hour. I'm sure some more folks will trickle in as we continue. Again, my name is Eli Scheele. I'm a principal engineer at GameBench, and today we're going to talk about automatically testing your game across 100 devices. And 100 is just a number. It could be 250, it could be 10 devices. What we're really talking about is the use of device farms and mobile game testing. So we'll just do a quick rundown of our agenda. I'm going to just do a brief introduction on GameBench and why we care about using device farms. We'll talk about the big question of why device farms, and what should we be trying to accomplish by using them. We'll discuss the differing types of device farms, local and cloud, and I'll also mention a bit about using sort of a hybrid solution. We'll talk about the way to actually collect and instrument your games for use on a device farm. And we'll talk a little bit about the data analysis of this data from your recorded sessions and how you can actually make that actionable. And we'll finally finish with a Q&A section. At any point during the presentation, if you have a question, please feel free to drop it into the question section on the GoToWebinar chat, and we will address them right at the Q&A section at the end there. Without further ado, I will jump into who GameBench is. So GameBench is a leader in the game performance management solutions space. We build tools for game studios, publishers, OEMs, all sorts of different parts of the ecosystem for performance management. When we talk about performance management, we're really specifically talking about things like system resource utilization, CPU, memory, GPU, frame rate stability. And we have collector tools and analysis tools that we work with our partners on developing and sharing with them so that they can maximize the performance of their games. We also have a lab service which works mostly on performance management consulting, where we can do independent verification of your game's performance across a wide range of devices. We can help troubleshoot and identify issues with your game. We also do a lot of work in the competitive analysis space, where we may compare your title against what you think are competing titles, or what we suggest as competing titles, to see how you stack up against the competition. Mobile gaming is a primary focus for GameBench. Most of our tools and solutions are targeted towards the mobile gaming space, both local and cloud gaming. And as a result of this, since we're building tools for mobile devices and we have a wide base of clients all over the world testing across a very broad ecosystem of devices, we have to test our tools to make sure that they work on these devices as well. So we use device farms to verify the performance and features of our own collector tools. So that's who GameBench is, and that's why device farms and automated testing are a big focus for us. Outside of our own internal uses, we see this broader trend in the industry as well of moving towards using both local and cloud device farms for testing to both catch bugs, reduce development cycles due to bugs, and to ensure compatibility across a wide range of devices for game titles. So the big why is a device farm something you should be looking into? And the reality is there's a huge diversity of devices that are out there in the ecosystem. And as our phones have gotten and tablets have gotten more and more powerful, people are hanging on to them longer. So that even adds more to the diversity of the devices. Even on the Apple side, you have at least a dozen devices that you have to test for just for iOS. Android, the fragmentation is much larger. You know, you're talking about thousands of different devices, and there's combinations of operating system chipsets and physical characteristics of the device itself that don't always ensure that your user gets a consistent experience across devices. And this is critical because you don't want to find out that a user has a problem with your game on the Play Store or on the App Store. You want to be able to catch any issues as early in the development cycle as possible, to prevent those sorts of issues from going out and being seen, and potentially losing an active user due to something that could have been caught much easier. So device farms really allow us to add another layer of testing before it gets to the client. So that's why device farms are really catching on. And when we're talking about device farms, we're usually talking about offerings that are local or cloud-based. And more recently, there's been emergence of this sort of blended hybrid model amongst some providers where they will sell a local device cabinet with their software framework and then have an integration into their cloud systems as well. But let's start with local device farms. So as the name suggests, local device farms are device farms that are on premises at your office or development studio. And it's a very broad category. There are some device farms that are homebrew solutions that individual studios have come up with on their own, just kind of piecemeal patch things together, pick up a test device or 2 or 3 or 5 and kind of make something work, all the way through pre-built vendor supplied cabinets. Like this bottom one is actually a picture of a Mobile Labs Gigafox. And they span that whole gamut of complete do-it-yourself all the way through white glove service. Here is your device cabinet. And being on-prem, you're going to have to dedicate some internal resources to your local device farm. Setup and maintenance are an ongoing task, especially as more and more devices are announced and released. And as your usage patterns change and user behaviors change as to what devices they're using, you're going to have to add devices to the cabinet, remove devices in some instances, manually or automatically find ways to change the operating system version if you're testing your software across multiple operating system versions. Then there's also the software itself for managing the device farm. For homebrew solutions, we see a lot of use of the project that used to be called OpenSDF and is now called Device Farmer. That is a very popular package. And then it runs the gamut of all sorts of different proprietary solutions that vendors will provide for you that will be, usually they're based on widely available open source projects, but they're packaged in a very specific way for that vendor. Another big cost in terms of labor that doesn't always get calculated into the decision-making process between local and cloud is the idea of resource control and scheduling. If you're at a larger studio that has teams working on multiple projects, multiple games, multiple titles, or even if you have one title and there's multiple developers working on differing features, access to resources and availability is a critical piece of the device farm experience. Being able to know, hey, I'm integrating this into my build pipeline. I need to have direct access to this as soon as possible because I want this to be something that's quick and get the results from. Now, being a local device farm, you have a lot more control around availability and accessibility, although you may have to dedicate some resources to it. You also have the option to get the specific devices that you care about. And this is a great feature to have because a lot of the cloud device farms may not have the 1 or 2 outdated devices or older devices that a significant portion of your user base may be using. And then being on-prem, there is that additional security aspect of it as well. This, you can set it up behind VPNs and firewalls to limit access to the device farms and prevent any leakage of any IP. So local device farms are, they're an investment, and I would highly recommend at least having a few devices set up in an organized way using a tool like OpenSTF, or some of these other packages out there for resource management and automated testing. And if it's appropriate for your studio to have a much larger cabinet, something like a Gigafox, be aware of the long-term costs associated with using and maintaining a local device farm. So I think that covers local device farms pretty well. Let's move on to cloud device farms. And cloud device farms, it seems like every week a new one's popping up. I am so sorry. I just realized I had my screen paused. Apologies. Hang on one second. I'm sure there's a note in the chat. Okay. So let's try this again. This time with my screen actually being shared. Again, my apologies. I did not realize I had the screen share frozen. So this is GameBench. This is who we are. And we will make a recording of this available after the webinar. And I will also attach a copy of this deck as well. GameBench, the Y, local device farms, and now cloud device farms. So like I was saying, there are a number of offerings in this space, and it seems like every week a new device farm is springing up. I just did a little research this morning as I was putting this slide together on who are the newest and latest players, and it's really overwhelming. And they differentiate themselves on a number of factors. Price is a big one. Device diversity is another big differentiator, and then the availability and utilization. So in other words, how you can actually, whether or not you can actually dedicate a device, similar to cloud platforms like AWS and GCP, where you could actually have reserved instances instead of spot instances. Some platforms allow you the ability to have reserved devices that only your software runs on. Nobody else gets access to it. Yeah, and a lot of these cloud device farms see that their offering is going to exist in some sort of build system. It isn't a standalone application or standalone use. So they'll have integrations into CI and CD pipelines, or APIs to automatically upload and test your APK or why am I blanking? IAP for the different platforms. Each of the cloud device farm platforms will support a differing amount of UI automation frameworks. Some of the cloud device farms that are out there have what they're calling AI-driven automation platforms. But there are some real limitations to having a cloud device farm that aren't present in a local device farm. Cloud device farm, the biggest one is you don't have physical access to the device. And that gives you a couple of limitations on things like power monitoring. Your device is always going to be plugged in unless you're big enough to work with one of these providers and negotiate the ability to have physical control of the access. It's very rare that happens. That also means for advanced interactions, anything that's using the accelerometer or gyroscope, or if you're using the camera in some sort of XR application, a phone sitting in a warehouse somewhere in a data center isn't going to give you direct access to that. You can use APIs to kind of simulate the that effect, but it's not going to be the same. Additionally, it's sitting inside of a data center somewhere, so you're not going to necessarily get real world data on things like network. Whereas if you had a local device farm, you could configure it to use the radio on the device itself, connect to Verizon or AT&T or T-Mobile in the US or any other number of carriers internationally and get the data there. So cloud device farms. If we look at like a really simple matrix of 3 of them, I just grabbed 3 device farms that are out there just to kind of show you how they kind of differ. So Samsung has their remote test lab, which is a great free offering that Samsung offers through their Samsung Developers Program. The trade-offs are that you don't have any other devices except for Samsung devices, which is great if you're testing specifically on Samsung devices, but most folks, when they're launching a game, are cross-platform, and they're definitely targeting more than one OEM. Samsung does allow you to have reservations of the devices. So you can say, I would like to use this particular Galaxy device for a half hour today. But it does not allow you to have a device dedicated to your testing. But it's free. And free is a great price for access to a service or just getting your toes in the water. One thing that the remote test lab is lacking, though, is some sort of API or integration into build pipelines. Now, if we look at Firebase Test Lab, that's Google's offering in this space, they have free and paid plans. So you can use the free offering for a limited number of minutes a day on device testing, or you can pay, and the minutes you can access are limited by your budget. They have iOS and Android devices. At this time, I don't believe it is possible to specifically reserve a device for your own testing, your own company on Firebase. But they do offer, both through their Firebase CLI and then through a REST API, automated access to the test lab. So you can integrate this into your build pipelines pretty easily for scheduling and reserving and actually running your tests. And then finally, at the end there, I have AWS's Device Farm. It is a paid offering. I do believe they offer a $100 free credit for the first month, just so you can get exposed to their ecosystem. They have a broad selection of iOS and Android devices, and you're allowed to specify which version of the operating system should be running on the device. They do have dedicated devices, so you can say, hey, I want to be running on an iPhone 7, running iOS 12.2, 0.1, whatever version of it, and you'll be the only client running on that device. So this does afford a little bit more security in the IP sense. You don't have to worry about somebody else running an application on that same device and somehow accessing some private data. Most of these services do wipe the devices completely between sessions, but there is always that concern. You can have a dedicated device set up through AWS Device Farm, and they do have a very well documented API, and there are, in fact, I know of at least 1 or 2 Jenkins plugins for AWS Device Farm that exist. And going back to the previous slide, there's a ton of offerings. Microsoft has their Xamarin Test platform that also offers a large number of devices. It's a paid offering with I think a limited number of free credits per month. This is a constantly changing ecosystem, and it's definitely worth taking your time on these cloud device farms to really, create the cost matrix that's hitting the KPIs that are most important to you. Now, what we've seen in the wild with a lot of our clients and with our own usage here at GameBench is a hybrid approach. Very frequently, there will be a small test lab or test device farm of 3 to 5 devices at a developer's desk or at a team's desk, or a team will have access to. That those 3 to 5 devices will be representative of how the studio has tiered their devices. So they will have one of the latest flagship phones, maybe a Samsung S20 Ultra. They'll have a couple of devices that are more mid-tier, and then they'll also have a couple of lower tier devices as well. Now, the way those tiering decisions are made is highly subjective, depending on your target audience, any sort of live ops data that you have about what devices your users are already using, etc. So each studio will have a slightly different portfolio of devices that are available locally. And then it'll be tied to a cloud device for more broader based testing, to hit a more representative sample of their users and the devices and software that they're running. At GameBench, we use a hybrid approach. We do a lot of more than 5 devices locally. We do a lot of local device testing in an automated fashion. And then we also, because our tools are used across a wide variety of devices by our partners all over the world, we use cloud device farms as well to verify the functionality and overhead of all of our tools and services we offer. So how do we actually get data from these platforms? Where does the data come from? How do we play our games in the cloud? That's a really, really big subject, and there's a bunch of different ways and a bunch of different tools that are out there for it. The first one are UI automation frameworks, and there are a ton of UI automation frameworks and UI drivers across both Android and iOS. From the vendor supplied ones, XCTest and UI Automator from iOS, or from Apple and Google, through cross-platform tools like Appium, Selenium, Calabash, and just tons and tons of different scripting languages and scripting interfaces to drive user interface interaction. And the cloud platforms and packaged local platforms support differing frameworks. And sometimes it can even be as granular as specific versions of frameworks are the only test scripts that will work on a platform. So when you're going through your platform decision-making process, it's very critical that you look at any sort of UI driver that you're going to use and make sure that it's going to work on the local and cloud platform of your choice. Now, unfortunately, most UI automation frameworks don't work very well in gaming. And that's because the UI elements that are present in gaming applications tend not to be from native renderers. They're rendered by the game engine itself. So there isn't a sort of tree, a hierarchy of UI elements for it to traverse and easily select. So there are limited applications of these UI automation frameworks. However, they are good for certain things. Any sort of flow where you're dealing with native UI elements, something like a UI, an in-app purchase flow. You're wanting to make sure that, from the game through whatever store experience they're going to have, that it's smooth and there are no barriers to the user completing the desired action. Ads is another space. When you have certain ad networks that use HTML5 ads, so there are a lot of playables that are in the space. Frameworks like Selenium work well with actually detecting the presence of the ad and you can do all sorts of instrumentation on things like load time, making sure that your ad networks aren't causing a performance issue by taking too long to load. And if you're doing something that is using an HTML5 like Canvas game that's wrapped, maybe you're in the hyper casual market and you're looking for something that gets developed very quickly, some of these tools like Selenium or Calabash will work really well on that. Now, those limitations of UI automation frameworks have given rise to a whole new swarm of AI automation frameworks. And I put AI in quotes for a lot of reasons. Usually they're actually less sexy than some all-knowing artificial intelligence that can pass a Turing test. Usually they're more computer vision based solutions that you train to recognize certain elements of your application. So buttons, menu elements, things around the presence or absence of different sprites or models. So they're great for smoke testing. Hey, when my app loads, I should see this logo. When I'm in a gameplay screen, these particular elements should be visible on the screen. So they're really good for smoke testing, really good for ensuring that you have all the graphical elements on screen as your game is being tested. However, the ones that do sort of gameplay AI aren't really representative of what your end users are going to experience or how they're going to play the game. Most sort of AI bots in the gaming space are still in early stages, and they're not very generalizable. An AI bot that can play a hyper casual game in a somewhat non-naturalistic manner is not going to be easily transferable to a AAA shooter title, like Call of Duty or PUBG. They're two different types of games, 2D versus 3D, two different types of interaction elements. It just gets too complex too quickly. Frequently, these AI solutions are proprietary and tied to a specific vendor that will offer a cloud or local device testing service. So that also ties in, if you're evaluating a platform, the presence or absence of some sort of AI testing is something that you can use in your evaluation matrix. AI testing for sort of like menu testing, screen testing, UI interface element, presence testing works really well. And we're seeing some really cool and interesting progress in this space. My own personal thought is that a generalizable AI that you can throw any game in front of and it just plays it well is a very, very, very long way off. But you got to use the tools that we've got, and this is one that's out there. And finally, we get to the good old game loop. And honestly, this is really the approach that we see the most use of with game studios, and it's something that we actually use ourselves. It's really easy to integrate into a DevOps framework or workflow. Basically, a lot of studios will set up a separate branch that has some sort of game manager script to run through the levels, and then as modifications are made to the game or features are added, that script is modified as well, and that branch is pulled, a special build is built, and that build of the game is run to collect this data. So what I mean by a game loop is basically you would have a script or library that accesses your game manager in your game and navigates the different scene transitions if you're in Unity, or loads particular parts of levels if you're using a different engine, uses some form of logging to indicate that it's in that state, Maybe it plays a little bit of gameplay to check things like frame rate stability, and then just continues on. One of the sort of side effects of having to build this sort of loop script is that it actually helps to enforce best practices around game architecture. Making sure that any modifications are modular and easy to use, that your state management is clean and very easy to document. So it really is a good way to kind of help enforce best practices on your development team. And since it's a tool that's written by you and controlled by your studio, you can be relatively assured that all areas that you're concerned about are going to actually be tested and run on the device, barring any sort of crash or other error that pops up. Of course, it is less naturalistic. It isn't actual gameplay. You're usually you're either capturing and replaying back inputs, or you're hard coding actions, or in our instance, what we do is, because we're not a game development studio, we take some available games that are out there and add our tools to them. And what we do is we actually disable things like lives lost. So this screen cap is actually of a Unity sample game called Trash Dash. It's one of my favorites to kind of tinker around with and experiment when we're building our tools. And we allow our hero character to collect all of the pickups and power-ups, but he is essentially immortal. So one of our flaws is we can't actually test any sort of death animation or anything that happens, or game over state from the game itself. So that is a consideration to look at. And we find that these sort of game loops, they provide a really good middle ground between a complete automated UI automation testing framework where you may not get the results that you're looking for, or the level of depth that you're looking for, and in-person testing where you actually have a tester that's been trained to capture specific segments of your game and will ensure that that happens. These are a good middle ground, and they offer a lot of benefits to the game development process beyond the testing. So those are like controlling the game. How do we actually collect data on metrics and the performance issues that we cared about, and making sure that we're monitoring and ensuring performance? On the cloud platforms, they offer a wide variety of metrics. Some of them are coming just straight from the device level. So they'll tell you total device utilization on things like memory, CPU, GPU. May not give you frame rate or frame rate stability statistics. That's a pretty rare option that we've seen. So it's a wide variety, and you may end up getting data from different sources or in different formats, depending on whether it's iOS or Android. At GameBench, we offer a tool called GameBench Automation, or GBA, which is primarily built for local device farms. I don't know of any deployments right now that are using a remote device farm, but primarily for local device farms. We have both a REST API and a command line integration available. So you can either incorporate it into a developer's workflow just by invoking the command line locally at their desk. And we also have the REST API. So if you have a centralized device farm that multiple developers are using, you can use this to start the monitoring of the devices. It is cross-platform iOS and Android. It collects all of the metrics that our collector tools, our desktop tool collects. So that is everything from FPS stability, CPU utilization, memory utilization, GPU utilization, network statistics, and of course all of the broken down statistics that fall into those categories, metrics that fall into those categories. And with the exposed APIs and CLI, it's really easy to integrate into a build pipeline, whether it's something that's living locally on a developer's desk or a centralized shared local device farm running on using something like Jenkins. And there's a good screenshot of a very, very simple pipeline where this is actually running locally on a developer's laptop, where it builds the game, it will install and run the game on a device, and then in this case, it's just verifying that we're hitting some memory and FPS thresholds. A second tool that GameBench offers in the data collection and metrics collection space is our GameBench SDK. And that works anywhere, local, cloud, anywhere you can run your app or your game, you can run the GameBench SDK. So this is really great for creating a sort of end-to-end metrics collection. You can have it on the developer's desk as they're working through a feature and building, all the way through, if it's pre-release and you have your team testing it on their own devices, and you've got your in-person testing, or you're using a service like Testronic where you have external testers doing the data collection for you, you can just get the data. Right now, it's available as a Unity plugin. So if you're working on a Unity game, we have it. It's drag and drop, very easy to configure. The results show right up on your GameBench web dashboard. We have a universal C++ library coming very, very soon. It will work on a development or a release build. You don't have to have any special flags turned on for this to work. And one of the really nice things is the ability to add custom markers, so you can highlight and analyze specific portions of your game, or you can analyze specific resources being loaded, unloaded, and making sure that the anticipated impact to your metric, whether it's memory for something, say, being loaded or unloaded, actually occurs. So you can create some pretty complex workflows and metrics flows from the data collected by the GameBench SDK. And just like I didn't mention this on GBA, GBA runs outside of the phone, so there is just the slightest amount of overhead for the metrics collection. The SDK, while running inside the game itself, has been designed and verified by using a combination of local and cloud device farms to have minimal resource impact on your game as it's running and collecting these metrics. So now we have identified our device farm or farms that we're using, and we have figured out a way to automatically collect the data, and we're getting all sorts of metrics data coming in. How do we make this data actionable? Data really isn't all that great if you can't actually learn something from it. And there are a few ways to make some real progress with this. The first is just very basic build pipeline integration work. Most of the cloud device services offer some form of an API or already existing plugin for the more popular build systems that are out there, whether it's Jenkins or CircleCI or anything else. So they really have a very simple way to get integrated right away, and you can set very basic thresholds around, am I blowing up my memory budget by adding this new model or texture into a scene, this new character that's being loaded? Is there a frame rate drop that's associated with it? Now, again, back to you do have to think about the scheduling and availability aspect of this when you're using it in a build pipeline. Just, let's say you wanted to test on a iPhone 6 or the latest and greatest, newest flagship phone. One, it might not be available on your cloud provider's platform. And two, if they do have access to the device, you may be competing with dozens or hundreds or thousands of other developers to test So in a build pipeline, which should be a very quick turnaround on whether or not something is red or green, that is a factor with the cloud platforms that you have to kind of build into your strategy around device testing. With our tools, GBA and SDK, the session data is accessible through our API. We have a Jenkins plugin that we'd be glad to share with you, and it's very easy to get set up and use in other build automation platforms as well. And really, when you're doing this sort of data collection, you're just looking for basic pass-fail. Do I blow my memory budget? Do I actually load this particular level? Is my CPU utilization above a certain threshold? Does the game, and sometimes it's just very basic questions that you're trying to answer. Does the game actually run on this device? One level down into the data beyond just a red and green is something like our GameBench SmartSheet. This is a tool that we've built for analyzing GameBench session data. And it's really nifty because what we can do is we can filter by build, we can filter by build number, we can filter by feature branch, however you want, wherever the data is collected, by user that collected the data or submitted the job. We have the ability to set custom thresholds and triggers for the metrics so that we can very easily look for more specific performance issues than, hey, does this just work? You can actually drill into, are we seeing things like stutters where we're seeing consecutive missed frames? Are we seeing spikes in network utilization around a specific portion of the game? So this tool is actually very accessible and very easy to set up, very powerful, and allows you to get a little bit more in depth on the specific problems that you're encountering. This is really great when you're testing across dozens or hundreds of devices simultaneously, in terms of being able to group failing tests and look for common patterns. It could be that the devices all share a specific chipset, or it's a version of the operating system. So this is a good way to get that next level down in terms of actionability. And again, being able to set these customizable thresholds by device or device family, being able to tiering, really makes it easy to tie this into something like a compatibility report as you're getting into your pre-release stage, when you're about to go live with a product, being able to say, hey, from our live ops data based on our current user base, this update will work across 100% or 90% of the devices that we're most commonly seeing. We should expect to see issues on these devices. And then you can make an intelligent decision based on your business needs, whether or not to spend a little bit more time addressing those issues or push something to release. And if you really want to get granular, with our tools at least, you can jump right into the dashboard. And this allows you to dive right into the individual sessions themselves and look at all of the metrics and see if you can identify specific issues with the application that you're testing. The individual session data is actually accessible from our Smartsheet. So if you're noticing an issue on one device that isn't present on other devices in its tier or in its operating system, you can just click right on it and jump right into it. The session data itself is very easy to share within or outside of an organization. So if you are working with multiple studios or teams located in different locations or on different products, it's very easy to share this data around. We also have a nice Jira integration. So as you're highlighting and looking at this data and you're preparing your tickets for your developers to address, you can link this data into that ticket, and then they will be instantly taken to it. And then we also have the ability to capture detailed logs with our GBA product. in addition to the time series data and screenshots that we capture as well. So you can really get a comprehensive picture of what is going on the phone when you're incurring or encountering issues. And finally, the last source of actionable data that we want to talk about are session videos. So this is actually a good instance of a capture that was done on AWS Device Farm. And this is just somebody trying to take a picture with the camera. And as you can see, because it's in some data center warehouse somewhere, what the camera sees is a wall, which is not exactly what ideal if you're building the next Pokemon Go and you need to actually see an AR experience. But depending on the solution that you use, you may have access to the actual video recording of the session. And this is great because this will provide you really, a direct view of what the experience is like. A couple of notes is that there are, depending on your platform, specific time limits on how long you can keep the session data and the session videos. So, the tools that tend to be free or very low cost tend to have lower retention limits, whereas the services where you're paying money, will have much longer storage limits. And they may actually tie into other cloud services and allow you to, offload the videos into something like S3 if you're using AWS's Device Farm. And then, the video itself, while it gives a very good picture of exactly what's going on and what the user is seeing, it's harder to actually cross-reference to other metrics data, including things like triggers on when a button was pressed and when the action was available on screen, or the specific metrics that we see in the GameBench time series information. Tying this to an externally recorded video isn't something that's automatic. Although with our screenshots that we captured, it actually probably would be relatively easy to correlate what you're seeing in a session video to the data present on the screen. So before we open it up for questions, I just want to really quickly do a summary. Device farms, they're really catching on. Every studio that I've been talking to is investigating some form of a cloud versus local solution or hybrid approach. With coronavirus and COVID-19, we've been seeing a larger migration towards cloud-based solutions just because, as I mentioned before, you need somebody to actually manage the resources. And if you can't be in your office, you can't really manage the resources. They help to reduce development time cycles. They help to identify bugs earlier in the process of development and really give you access to dozens or hundreds, potentially thousands of devices that you may not have in-house. We use these techniques for our own internal use. All of the GameBench tools are verified against either a local or cloud or sometimes both farm, and it's a constantly growing sector. And at this time, I think I will take some questions. I think I see some. Here we go. So we've got a question here about the overhead of the GameBench tools. So a little clarification on that. Anytime you're doing any sort of monitoring, you're going to encounter overhead. There really isn't a way to monitor the performance of an application without using some resources. Our tools are built specifically to be as minimal in their overhead as possible. So GBA is actually sort of a fork or an automated version of our desktop tool. And since most of the metrics collection framework sits outside of the phone itself, we have extremely low impact on the performance of an application running on it. And also we're using APIs that are already exposed in for a lot of our metrics. So these are processes that are already running in the background. We're just collecting the data from it and packaging it up and visualizing it in a way that's consistent between platforms and devices. The overhead on the SDK, because the SDK is actually doing the performance collection as the game is running on the phone itself or tablet, there's a slightly larger overhead. I believe at this point it's less than 1% CPU on Android, and I believe it's less than 1/10% on iOS. We just pushed a new version of the SDK out today, 0.61, or 0.6.1, where I don't have I'll have to pull up the latest performance impacts on that, but it should be in line with that. And then another collector tool that we do have available is our GameBench Android app, and it has a performance impact that is slightly higher than the desktop app because it does, collect the session data and store it on the phone as the data is coming in. So that's the concern in terms of overhead of our tools with GBA and SDK. Okay, let's just pop this up. Do we have any other questions? Okay. Well, I want to thank everybody for attending the webinar or watching the recording. I really do apologize about having my screen share paused for the first few minutes or so. We will definitely send out this video and the deck to everybody so you can peruse and share with your colleagues as you want. Like I said, we do a lot of work in this space. A lot of our clients are using cloud and local device farms. So, if you have any questions about integration, or if we've looked at a particular solution with a GameBench tool, or our thoughts on particular AI packages for automated game testing on device farms, feel free to reach out. My email is eli@gamebench.net. I'd love to chat and help design or help you work through designing the most appropriate device farm testing solution for your organization. And thanks for coming, and have a pleasant day.